Question 53, Instrumentation Engineering, Gate 2021. For the full bridge made of linear strain gauges with a gauge factor of 2 as shown in the diagram, R1, R2, R3, R4 is equal to 100 ohm at 0 degrees Celsius and strain is 0. The temperature coefficient of resistance of the strain gauges used is 0.005 per degree Celsius. All strain gauges are made of same material and they are exposed to the same temperature. While measuring a strain of 0.01 at a temperature of 50 degrees Celsius, the output V0 in millivolt is dash. This is rounded off to 2 decimal places. Let us have a basic idea about the working of a full bridge strain gauge and then solve this problem. This is in the form of Wheatstone's bridge arrangement, and according to the given problem, this is R1, this is R2, this is R3 and this is R4. This is the plus terminal and this is the minus terminal. Here this strain gauge works on the principle of expansion of resistance. The resistance expands to delta R due to the strain applied, and the change in resistance delta R by R is equal to the strain multiplied by the gauge factor, where this epsilon denotes to the strain. In a full bridge strain gauge, one pair of resistance will expand its resistance due to the applied strain and the other pair will contract due to the applied strain. This is because when all four resistors have same resistance due to the applied strain, what will happen? The bridge will be balanced and the output will be 0 volt. To avoid this, it will be wired in such a way that one pair expands and the other pair contracts. Due to this, what happens? The resistances R1 and R4 will become R1 plus delta R and it will become R4 plus delta R, or the strain will add upon these resistances. But for the resistances R2 and R3, it will become R2 minus delta R and R3 minus delta R. This is the changed resistance due to the applied strain. So, as a result of the change in resistances, the Wheatstone's bridge will not be balanced and there will be a voltage across these ends. This voltage is what is asked. In the given problem, this strain gauge has two effects. One is the temperature effect and the other one is the strain effect. We saw the aspect of strain now. Now let us see the temperature aspect. Resistance expands due to temperature. The changed resistance RT is equal to R0 into 1 plus alpha delta T, where R0 is the resistance at 0 degrees Celsius, delta is the temperature coefficient of resistance, T is the change in temperature, delta T is the change in temperature, where reference is considered as 0 degrees Celsius. RT is the changed resistance. Let us solve this problem. The given details is the gauge factor is equal to 2 and all the four resistors have the same resistance of 100 ohm at 0 degrees Celsius. So, R1 equal to R2 equal to R3 equal to R4 is equal to 100 ohm at 0 degrees Celsius. It is mentioned that there is a temperature acting on these resistors as well as there is a strain acting on these resistors. Due to the temperature effects, the R dash, which is equal to 100 into 1 plus 0.005 into 50. So, R dash is equal to 125 ohm. Therefore, the change in resistance due to temperature is denoted as delta RT. This is equal to 25 ohm. Let us see the effect of strain. Let me denote this as delta R1 to differentiate the change in resistance between the temperature and the strain. So, delta R1 divided by R is equal to strain multiplied by the gauge factor. So, delta R1 divided by 100 is equal to 0.01 multiplied by 2. Therefore, delta R1 is equal to 2. What happens is R1 and R4 expands and R2 and R3 will contract. Therefore, the changed resistance of this is 25 plus 2, which is equal to 27 ohm, and the changed resistance of this is 25 minus 2, which is 23 ohm. Therefore, R1 is equal to 27 ohm, R4 is equal to 27 ohm, this is 23 ohm, and this is also 23 ohm. Therefore, V0 is equal to the voltage between the voltage across R2 and R4. The current 1 milliampere will split as 0.5 milliampere into each amps because the current gets divided equally. The voltage across R2, let us denote that to be VR2. The voltage across R2 is equal to 0.5 milliampere into 23, and the voltage across R4 is equal to 0.5 milliamperes into 27. Therefore, the difference in voltage V0 is equal to 2 millivolt. 2 millivolt will be measured across these two ends. Thank you.